Hey everyone, welcome back. And today is going to be an interesting topic. Okay, so we are going to solve a question where it involves a theory part. Okay, so theory plus practical. So this excellent question is from Hoonartek. It's a recent question. We have got this info from a candidate. So we'll just solve this one. Okay, today. So and then it will be helpful for you guys. Okay, so if you are if you are crossed 4 or 5 plus. Okay, so this question is typically for 3 to 6. Okay, so 3 to 6 years of experience, you know there are like 3 to 5 years. Okay, so I'm not sure about seniors. Okay, but juniors you can apply to Hoonartek. Okay, so what this question about, find all parallelism in this graph. Okay, so you have to find all the type of parallelism present in that graph. Okay, so which recruiter gives you. So we'll solve this question. Okay, so if you're new to the channel, you can click on the link above. So please go through all the interview videos. Okay, interview questions related videos. So it will be really helpful if you solve when you go to the interviews. Okay, so first one, years of experience is 3 to 6, and then expectation is that recruiters typically they expect. Okay, see, the questions evolve. Okay, so questions even they evolve. Okay, so uh, we get practical questions. Okay, so practical use cases, and then real time. Okay, so real time, and then dynamic questions. Okay, so like that, this one is quite bit. Okay, quite theory plus practical. Okay, so you have to apply. It's kind of application oriented. Okay, so you have to apply your concepts. Okay, so concepts, if you understand the parallelisms. Okay, so mainly the concepts secured for this use case, to solve this use case is parallelism. So I already made a video on parallelism. Okay, so go and check it out. Okay, so I'll just ping the link above. I just made, I think, I just made a roll up, I think, related to roll up and since. Okay, where pipeline parallelism. Okay, so I made a one video on pipeline parallelism. Okay, so it's roll up, whether roll up will break that or not. Okay, so that one is quite different. Okay, so now we'll see all this type of parallelism in this question. Okay, so in this question, I haven't made a video on type of parallelism. Okay, so today we'll just discuss on the type of parallelism involved in this graph. So while discussing that, while discussing this practical use case, you'll get to know about the entire types. Okay, and then you'll understand that as well. Okay, so you need to understand that parallelism and then types of parallelism. Okay, so type of parallelism in Abinitio. Okay, so these concepts are very important. No, you need to know how to differentiate. Okay, so because when you become an architect, let's say you're becoming an architect in future. Okay, so data architect, so in that case, like, you should know. See, Ab initio is mainly parallelism. Okay, so it has got parallelism future. So you should know how to build a robust graphs. Okay, so for that, parallelism and partitions. Okay, so they are really highly important. Okay, highly important for for designing. Okay, so that's it. Okay, so that's it. So we will just look at the graph. Okay, so Rocket has given the specified graph. So this one is a specified graph. Okay, so input file, and then partition. Okay, so normalize, filter, replicate, and then we are taking that flow into roll up and reformat, and then we are getting, maybe we are getting some more report here. Okay, let's say report output. Okay, and then some normal output, report output. Okay, op. Okay, report output, and then some other output. Okay, some aggregation output. Okay, so how do you, okay, first one, how do you do the analysis? Okay, so see, for this use case, you have to think in a manner. Okay, so when you're presented with a graph. Okay, so this question can be new to you guys, but the thing is, when you do the analysis. Okay, so analysis first part. Okay, so this one is nothing but pure graph analysis. Okay, so it's a fresher type of question, and plus when you decode, it will get into your senior level expectations. Okay, like 3 to 6. Okay, so as a fresher, you already see, you already know the graphs are components connected like connected, interconnected. Okay, interconnected. Okay, so you have to differentiate what is happening, and then where the type of parallelism. Okay, where the parallelism comes into picture. Okay, so for that, you should know the idea of graph. Okay, so graph and then types of parallelism. So first we'll understand the graph. Okay, so in this graph, what do you see? Okay, so I'll just okay, so in the analysis part, okay, for this use case, what do you say actually? So in the input side, we have a serial file. Okay, so I'll just decode. Okay, so let me just decode. Okay, so input it's serial. Okay, input is a serial file. See, one-way partition, right? So no partition. Okay, so it's a single file. Okay, serial file that's going into partition by key, and then here after this partition. Okay, so maybe okay, so here we are doing that partition. Okay, so after this till the output we are generating. Okay, so mfs file. Okay, so your output it's nothing but mfs. Okay, so that is mfs. Okay, so other thing. Okay, so other thing is that from the end to from the starting. Okay, so like serial file is getting partition, and then it's going to various components. Okay, so here replicate is there. Okay, so replicate, and then same data is going to two different components. Okay, so one thing I analyze is that from the end to end. Okay, the graph is structured from the end to end. Okay, so the graph is structured. Okay, structured from end to end. Okay, connecting top stream, like upstream and to the downstream. Okay, so your downstream is nothing but that report file and everything. So the report will constantly wait for the upstream files. Okay, upstream data. Okay, so that one we notice, and then we notice replicate. Okay, so we are replicating the same data and then flowing into different components. Okay, so note down this one. See, we are noting on, we are decoding these things because it will be helpful when you find out the type of parallelism. Okay, so replicate. Okay, so note down replicate is okay, like taking the data. Okay, so convert. Okay, so that replicate is happening after filter. Okay, so we are replicating the data, and then and then after replicating, let's say after replicating the data, and then taking them to taking two different components. Okay, okay, so data, and then taking the same data. Okay, same data to two different components. Okay, so now we'll come to now we'll understand see partition. The see when you see a graph, you have to understand whether serial file. Okay, so it has got serial file, mfs file, either part. See, if it's a serial to mfs, then partition is going on. Okay, so let's say partition is going on. Okay, so partition is going on, so note down that one as well. Okay, and then graph is structured. Okay, so from it's like a kind of pipeline. Okay, from end to end. Okay, so that one, and then replication is going on. Okay, and then same data to two different components. Okay, so if you note down this one, same data. Okay, so same data is going to two different components. Okay, so now we'll come to the type of components. Okay, type of parallelisms. Okay, so here let's say I'll come to components later. First, see, the recruiter's question is, question is find all parallelism in this graph. To find all the parallelism, you have to note down the components, right? See, your end, aim. Okay, so let's say, I will just put it here. Okay, so your goal is to find components. Okay, so goal is to find components responsible for that parallelism. Okay, so that's how you'll find the parallelism, right? So actually goal is to find the components involved. Okay, so involved in parallelism, in different in different parallelism. Okay, so in a different parallelism. Okay, so that's the goal. Okay, to find the component. Okay, so what are the components we'll see in the last. Okay, so just take so first we are just analyze the graph, and then we are going to see unless we'll just see the component straight away, but before that I will tell you the types. Okay, so types here we have got let's say we I think you know about the type already. Okay, so I will just tell you we got pipeline. Okay, we have got pipeline, and then we have got let's say we have got data, and then we have got component. Okay, so we got three types of parallelism. Okay, so if you want to study more theory into this one, you can go and check it out, check it out in this site. Okay, docs.abinitio.com. You will have a trainings and then theory. Okay, so they provide that. So basically, I'll just tell you in a few words. Okay, so pipeline is nothing but it's structured. Okay, data structured in a way that flows from upstream to downstream. You just remember, you have upstream to downstream. Okay, upstream downstream. So, and data parallelism is nothing but you know uh, parallelism in between partitions. Okay, so that's parallelism in between various partitions, basically various partitions. Okay, so and then component parallelism. So here is nothing but same data. Okay, same data into, let's say, different into different partitions. Okay, into different components, sorry, to different components. Okay, so it can be two or three or whatever. Okay, so these are the one line definition. So there are a lot of theories involved. Okay, a lot of theories and example. I just recommend you to go to that official site. Okay, so that's how, see, we have analyzed the graph, and then we, these are the types. Now you can easily find out the components. Okay, so now we'll find out. So first we will take pipeline parallelism. So pipeline parallelism, you know so recruiter will expect you to find out what is happening in the graph, right? So I would say from the input. Okay, from the input to the output. Okay, so that flow. Okay, parallelism occurs from the input. Okay, so input long, okay, straight away to the downstream. Okay, so which is nothing but report and other output, right? So max output. Okay, so this one. Okay, so from here to there. Okay, so from upstream to downstream, the grassy, that pipeline parallelism occurs. Okay, from the upstream to the downstream. Okay, so that's one type. Okay, so you can tell them. And another thing is data parallelism. Okay, so here, okay, so we have solved this one. Well, data parallelism is something but various partitions, right? So where do you see the partitions? Okay, so where do you see the partition happening? Okay, input, after that partition. Okay, so after that see, after that for flows are going here, and then creating this one. Okay, so basically apart from the input and replicate. Okay, so everything, okay, all other thing will come into data parallelism. Okay, so parallelism. Okay, say except, I think, except input file. Okay, and say input file, all the components, okay, will come into data parallelism. Okay, so because the partitions are there. Okay, so and then component parallelism. Okay, so here, okay, those, see, this one is except input file. Okay, and this one is from the stretch. Okay, from the input to output. Okay, so input output, and you can tell the name of the component as well. Okay, when you come to last component parallelism, here's what's happening. Okay, so after replicate, so you have to tell them, after replicate we are taking a same data and then go putting it into different components. Okay, two different components. So here, after replicate, okay, so you have to take the flow after replicate. After replicate, the roll up and then reformat. So this one plays important role. Okay, so this one actually plays important role in component parallelism. Okay, so here roll up and reformat. Okay, so that's how you have to identify. Okay, so roll up and reformat, because before that same data is going inside, and then various functions or operations are happening here, and then it's flowing outside. Okay, so it's kind of same data into different components. So that's how you can able to find out the component details along with the along with understanding the theory topics. Okay, so basically applying the theory concepts into this use case. So nothing to nothing else to crack on this one. Okay, so it's pretty easy one. If you understand the concepts very well. Okay, so easy to solve even if you're a fresher, even if you are 3+ years experience. Okay, so understand the graph, understand the, if you have any doubts in the theories, you can go and watch here on abinitio.com. Okay, so docs.abinitio.com. So I'll just come up with another different idea. Okay, so different questions which we have got. So until then, you can solve this. Okay, solve this, practice this, and then do watch other, other videos. Okay, so other videos now, other segregated compound videos. Okay, so if you have any queries, you can mail us. So I'll just see you guys in the next video. Okay, until then, tata. Bye.